Okay, this is the first example we are going to do. First of all, we will be discussing the first case. So we will have many cases. The first case when the standard deviation of the population is known, as we did in chapter 8. When the standard deviation of the population is known, then we will be able to use the z-test, or we'll be able to use the standard normal distribution. So let's look at this example. Mountain State Surgery performs many knee replacement procedures every year. Research physicians, they developed a surgery procedure they believe will reduce the average patient recovery time. This is a key statement. This is now a key statement. Why is that? Because this is what they are claiming. They are claiming that the new procedure is going to reduce the average patient recovery time. So the average mu is going to be less than the recovery time. The hospital board will not recommend the new procedure unless there is an evidence to suggest that it's better than the existing procedure. So they need evidence to support that claim. Records indicate that the current mean recovery time for the existing procedure is 142 days. So this is the hypothesized, this is 140. This is the hypothesized mean. This is the hypothesized mean. So what they are saying, the physicians, they are saying that, oh, we have a new surgery that we can actually reduce the recovery time to be less than 142. This is my alternative hypothesis. Because this is the claim, they have to support this claim. The default situation, the default scenario is the recovery time basically is exceeding or it's equal to 140 days and exceeding 140 days. So this is how we formulate our null hypothesis and alternative hypothesis. Why is that? Because the default, what is the default situation? The default is it's not less than 140 days. It's 140 days, it's equal 140 days and exceeding 140 days. But they are suggesting a new recovery or a new recovery time, a new surgery that will reduce the recovery time. So this is the claim. So this is our alternative hypothesis. Or you can look at in terms of equal and non-equal. If you have seen the equal sign, for example, they believe will reduce the average patient recovery time. This is actually doesn't contain the equal sign. So this is going to be your alternative hypothesis. So our null hypothesis, the mean is going to be greater than or equal to 140 days as a recovery time. The alternative hypothesis, the new procedure, is going to reduce the recovery time and is going to be less than 140 days. And if you look at the sigma, then the sigma standard deviation is 15 days. So they are going to test this claim. To test this, they performed a new procedure on a sample of 36 patients. And they found that the sample mean is 140.2 days, which is actually less than for 142. So the X bar test is 140.2 days, right? The researchers wish to test the hypothesis using 5% level of confidence. So this is my alpha. So I am stating here the three methods. There's no need to do all of the three methods. You can use only one of them to conclude your result, but I'm going to show you how to do all of them using Minitab. So let's go to Minitab and let's go to stat, basic statistics. Then we're going to go to one sample test, z-test. Again, because the standard deviation of the population is known, we can use the z-test. And you have to put this in your mind that if we don't know anything about the population distribution, if the population distribution is normal, then the sampling distribution is immediately going to be normal. But because we don't know anything about the population distribution, however, we have a big sample size, which is greater than 30, we have 36, then we can say the sampling distribution is normal, okay? So we're going to use one sample z-test. We have two options, one or more samples in each column if we have columns, but now we have the summarized data. What is the sample size? 36. What is the sample mean? Sample mean 140.2. What is the non-standard deviation? Do we have it? Yes, 15. By the way, is that right tail or left tail test? This is a left tail test because we look at the alternative hypothesis. Mu is less than, so we're going to look at the left-hand side, not the right. The hypothesized mean, it's 142 days. We're going to take the performing hypothesis test, check. What is the confidence level? The confidence level is 95% because the significance level is alpha 5%. What is the relation between the confidence level and significance level? 1 minus significance level equals confidence level. 1 minus significance level equals confidence level, or 1 minus the confidence level equals significance level, right? Because alpha is 5%, 1 minus 5% is 95%. So the question asks you about the confidence level, not the significance level, okay? The alternative hypothesis is what? Is mean less than the hypothesized mean. Mean less than hypothesized mean. Okay. Now, what do we have here? We have descriptive statistics about the mean, the sample size, about the standard error, and this is the upper bound of the confidence interval. This is the testing now. We have the null hypothesis, which is mu is equal or greater than or equal 142. Why did I say greater than? Because the alternative hypothesis is less than, so that one's going to be greater than or equal. Now we have the p-values here. We have the z-test. This is the z-test value. This is the testing. Okay? This is the standardized z value of the X bar test. This is the standardized value of 140.2. Okay? So I'm going to place them here. The p-value is 0.26 and the z-test negative 0.72. Good. Method 2 is complete. Now we can conclude the p-value is greater than the alpha. Because the p-value, this area is greater than the alpha area, then we are not in the rejection region. We are far from the rejection region. So what we do, we fail to reject the null hypothesis. We fail to reject the null hypothesis. And what? There is no sufficient evidence to conclude that the new knee replacement procedure will result in a shorter recovery time. Shorter average recovery time. The mountain states will not be able to recommend the new procedure based on what it reduces recovery time. Okay? On the ground. So if you fail to reject the null hypothesis, we fail to reject this fact. You don't have evidence to support this fact. You don't have evidence to support this second fact here. So that means we will not be able to recommend that new procedure. But this is enough, but let's find the X bar critical and Z critical. And this isn't easy to be done because we can go to graph, probability distribution plot. Let's find first the Z critical. The Z critical, what is the Z critical? We have the mean is 0, the standard deviation is 1 because we're looking for the standard normal distribution, is the Z value. Options, is it right or left tail? It's left tail. Left tail, what is the probability on the left tail? It's 5%, right? So what is the Z value? It's negative 1.6, negative 1.645. So this is what? This is our Z critical. Now, what is X bar critical? X bar critical, we go again to graph. We have to be careful here. We have to go to the probability, view probability. The mean is 142 days. Standard deviation, this is important. Why it's important and critical? Because we are now graphing, so sampling distribution. So we have to put the standard error here. What is the standard error? Is the standard deviation divided by the square root of n. So the standard error, standard error, let me put it here, standard error equals what? Equals to the standard deviation, which is sigma, right? Divided by square root of what? Of 36, of n, right? So this is equal to 15 divided by square root of 36, which is 15 divided by 6, which is what? 5 over 2, right? So 3 divided over 2, which is 2.5. So it's 2.5 is the standard error. 15, 3, 3, 5, and 2, yes. And for the options, is it right tail or left tail? It's left tail. What is alpha? Alpha is 5%, so this is equal. Now, what is the time here? It's 137.9 days. So our 140.2 days is located here, somewhere here. So 140.2 is greater than 137.9. And this is, look, this is the critical, so this is my rejection region. This is my cutoff value, 137.9. This is my rejection region, 5%. So the p-value is greater than 5%. What is the p-value? The p-value is the area at the left-hand side of what? Of the 140.2. 140.2 has an area at the left-hand side of this one is this one, right? Which is the same area existed, at the left-hand side of the z-value, if you have standardized normal distribution. Now let's focus on the normal distribution, only these two. So this is 140.2 is going to be somewhere here. Let's say it's here. So the area on the left, all of this is going to be 0.236, the p-value, which is greater than the alpha, the rejection region. So that's why we fail to reject the null hypotheses. Any of the methods will be working. If you use any of these three, will help you to get the same result at the end.